Grounding system. When an electrical system is connected to the earth, either intentionally or accidentally, it is said to be grounded. In general, all building electrical systems are intentionally grounded at the point where the voltage to the ground is the lowest. There are several reasons for grounding. One, grounding protection protects the system and equipment from overvoltage due to accidental contact with the higher voltage source, such as the primary voltage side of the distribution system, which may exceed several hundreds, thousands of volts. When lightning strikes a building that is electrically system, electric wiring and insulation equipment may break down, and lightning current will flash over to shake the ground. If the system is properly grounded, the lightning current will follow a direct path to the ground by passing the feeder and equipment. 3. Grounding protects people from heavy electrical shock. If the system and equipment are grounded and the electrical circuit is accidentally shortened to the equipment, the circuit protection device, fuse, or circuit breaker should trip and cut off the circuit. If the system is not grounded, then any accidental grounding of the wire through the equipment may pass through a person who happened to be touching the equipment. Number 4, a grounded system is more economical than ungrounded one. The grounded side of a circuit must not be switched. Thus, on a single-phase circuit, only a single pole switch is required, whereas a double pole switch must be used on ungrounded single-phase system. Ground fault circuit interrupter for added safety. Certain receptacles and circuits that supply load for swimming pools, kitchen, garages, bathrooms, laundries, or outdoor equipment should be of the type that can trip or cut out the circuit if an imbalance or current flow is sensed between the grounded and ungrounded side of the circuit. Such an imbalance indicates that current is leaking through the ungrounded side of the circuit. Thus, the situation should be corrected by a ground fault circuit interrupter. Opacities of electrical conductor. Current carrying capacity. The current that can be carried by a conductor depends on the size of the conductor as well as the type of insulation. Method of installation. Number of wires within a raceway and surrounding temperature. The allowable current carrying capacities or opacities of various types and sizes of wires are given in the National Electric Code. Opacity is defined as the ability of the conductor or electrical wire to carry current without overheating. Conductors' resistance to current not only generate heat but also distribute to the voltage drop expressed as voltage drop in wire equals to circuit current times the resistance of wire. Power loss in wire is equal to circuit current multiplied by the voltage drop. So power, therefore, is equivalent to I times resistance. And therefore, P equals to I raised to the second power times resistance. This is the table for wire size and ampere capacity. We have here an American wire gauge having wire sizes of number 14. It can carry 15 ampere. Number 12 can carry 20 ampere. Number 10 can carry 30 ampere. Number 8 can carry 40 ampere. Number 6 can carry 55 ampere. Number 4 can carry 70 ampere. Number 2 can carry 95 ampere. Number 0 can carry 125 ampere. Number 00 can carry 145 ampere. And number 000 can carry 165 ampere. Power loss is equal to the component's resistance times the current squared. The power loss in wiring, which is converted to heat, must be dissipated. A small diameter wire can safely carry more current in proportion to its weight than a large diameter wire. Thus, less copper is used to carry the same amount of power in a higher voltage current. Under the principles of Ohm's law, a 1200 watts appliance rating, the current flow is 10 ampere at a 120 volt supply of current. So this solution, 1200 watts divided by 120 volt is equivalent to 10 amperes. The current drawn from the 240 volt current supply is 5 amperes. So the solution is having same load consuming device, which is actually equivalent to 1200 watts, and divided by 240 volt is 5 amperes, which is only half of 10 amperes current drawn from a 120 volt current supply. If basic wire insulation is rated at 300 volt, the same amount of power can be carried with less than half the cost of the copper. This is the reason for the worldwide acceptance of 240 volt current gained its most favored. An advantage of using 240 volts over 120 volt current has its following advantages. Number 1, smaller wire is required, which means lower cost. Number 2, less power loss. Number 3, smaller percentage of voltage drop. The rating, ampacity or building of the conductor to carry increases as conductor size increases. If more than 3 conductors are inserted into a conduit, temperature increases and it requires the rating of conductor's ampacity. The rating of conductor's ampacity means that the full amount of allowable ampacity of conductor is reduced to a certain percentage due to environmental condition, the conductor is exposed, and the number of wires placed inside the conduit. The rating of conductor's ampacity means that the full amount of allowable ampacity is reduced to a certain percentage due to environmental condition. It is exposed, and the number of wires placed inside the conduit, the current rating of wire in free air environment is higher than those placed inside the conduit. Concomitant with this, if the ambient temperature is above 30 degrees, The allowable ampacity will be reduced by the factors given in this table. Current carrying capacity, the rating factors. Number of conductors inside the raceway from 4 to 6, the rating factor 0.80. From 4 to 24, the rating factor 0.70. From 25 to 42, the rating factor 0.60. 43 and above, the rating factor is 0.50. Graphical symbols in electricity. Graphic symbol in electricity, there are situations where it is impractical to draw pictures directly on paper. However, this is made possible without altering the very meaning of the same objects through the use of symbols in electricity. A lot of things are represented in symbols. The electricians find it convenient to draw or read schematic diagrams. A schematic diagram is actually a blueprint. It has meaning, which tells how the electrical parts are connected in a specific circuit. Protective devices, electrical circuits that include feeder, distribution equipment, branch circuits, and the load equipment must be protected from exceeding their rated capacity, which may occur as a result of many circumstances. Some examples are overcurrent due to mechanical overload or internal or external electrical faults. Overvoltage due to short circuiting between primary and secondary wiring or due to a lightning strike. Reverse in polarity of a three-phase system due to a change of power service. The most common method used to prevent the damage caused by overloading conditions in installation of protective devices at a strategic location. Example on switchboards, on panel boards, at the beginning of a feeder, in a branch circuit, or at the equipment. These devices are divided into three general types: relays, circuit breakers, and fuses. Relays are normally used by the utility companies to protect their primary distribution system or large primary equipment within a network. For billing system and equipment, only circuit breakers and fuses are usually used. Circuit breakers. Classification of circuit breaker. A circuit breaker is defined as a device designed to open and close a circuit by non-automatic means, and to open the circuit automatically on a predetermined overcurrent without damage. When properly applied with its rating, there are three types of circuit breaker. Number one is the molded case circuit breaker. The current carrying parts mechanisms and trip devices are completely contained within a molded case of insulating material. The MCCBs are available in small and medium frame sizes from 30 ampere to 800 ampere, and with trip sizes from 15 ampere to 800 ampere. Second, low voltage power circuit breaker. These circuit breaker are also known as air breakers. They are primarily used in draw-out switchgear construction. Draw-out circuit breaker are mounted on rails, which are pulled out like a drawer for ease of maintenance. LV PCBs have replaceable contacts that are designed to be maintained in the field. LV PCBs are available in medium and large frame sizes from 600 ampere to 4000 ampere. LV PCBs are rated from 600 volt, whereas NV PCBs are rated up to 72.5 kV and HV PCBs for over 72.5 kV. Third, insulated cased circuit breakers. These have the construction characteristic of both MCCBs and LVPCBs and are used primarily in fixed mounted switchboards but are also available in throughout configuration. The frame sizes range from 600 ampere to 4000 ampere. Operating principles of circuit breaker. There are two types of circuit breaking: tripping components within a circuit breaker. Bimetal or electromagnetic type consists of a bimetal elements which responds to temperature built up inside the circuit breaker, and an electromagnet which responds to the magnetic force caused by an abnormally high current flow. The bimetal provides thermal protection and the magnet provides circuit protection. Number two is the solid state electronic type. Consists of analog or digital devices to sense the electrical characteristics or circumstances of the circuit and process the data through a central processing unit or CPU. With a predetermined program's actions, the analog type senses the peak current, while the digital type senses the RMS current of the current flow. The RMS value is a more realistic representation of the AC current. The operating principle of a digital type solid state circuit breaker. Advantages of circuit breakers. The advantage of circuit breaker over types of protection devices, namely the fuses, easily resettable when the system is tripped, more compact, adaptable for remote control and electrical interlock with other equipment, can serve as a disconnect switch, although should not be used as an operating switch. Fuses. A fuse is an electrical protective device that melts upon sensing an abnormal current and opens the circuit in which it is installed. Fuse is a self-destructive device. Classification of fuses. There are many types of fuses classified as follows. 1. Voltage class. It has 12, 24, 125, 250, 600, and 5000, and higher voltages. 2. Current rating from a fraction of an ampere to 6000 amperes. 3. Construction. Non-renewable or renewable. Single or dual elements. Number 4. Principle of operation. Fast clearing, time delay, current limiting. Number 5. Short circuit interrupting capacity, 5000 ampere to 200 ampere. Fusible material, lead, tin, copper, silver, etc. Operating principle of fuses. The operating principle of a single element fuse is very simple. The fusible link is made of a lead, tin, antimony, eutectic alloy that has a single temperature. Melting point without softening. Prior to reaching its melting point, the fusible element is precisely made, having bottlenecks, narrow section that melt upon overheating due to a higher current flow. The dual element fuses, as are time delay fuses, each consists of two fusible elements under normal operating conditions. The time delay element will break loose when the fusible material holding the S connector is melted. Because a heat sink is attached to the S connector, the melting is intentionally delayed to avoid nuisance tripping of the connected load, such as a motor load. A motor load has a high inrush during startup. If there are no time delay to compensate for the high inrush current, then the motor load will be cleared before it can be started. Advantages of fuses. Two major advantages of fuses are that they are fast acting and self-coordinating in a properly designed distribution system. If the same class of fuse is used at all levels of protection, the lower level fuses, naturally the smaller in ampere ratings, will clear first and prevent interruption of the upper level fuses. Circuit symbols. We will now discuss briefly how to find circuits in your home. A circuit consists of all lights and receptacles connected to one pair of wires from the fuse box. These were shown and can be seen in papers. A circuit is described by a certain symbology, which shows what the devices, receptacles, switches, lights are, where they should be located. Riser diagrams. When all devices are circuited and panels are located and scheduled, we are ready to prepare a riser diagram. A typical diagram represents a block version of single line diagram, except that, as the name implies, vertical relationships are shown. All panels, feeders, switches, switchboards, and major components are shown up to but not including branch circuits diagram. An electrical version of a vertical section taken through the building. Some definitions. At this stage, we must become just a little technical. There are some terms you must be familiar with if you are to understand and be able to talk about electricity. There are three major terms, and these you have probably heard before. One, volt. This is the unit of pressure in the electrical system. It is abbreviated V. To have 10 volt is like having 10 pounds of water pressure. The more volt you have, the more electricity will be forced to flow, and the more dangerous the system becomes. Normally, you will have 120 volt for lighting, and at the receptacle outlets, you will have 220 volt for the range, the cloth dryer, and the shop tools of large size like a lathe. The number of volts which you use is important when you ask for wire to add to your home circuits or install new circuits in a new home. As you can readily imagine, if you use a wire which has a covering, we are referring to the insulation designed to contain 10 volts. This same covering might rupture if you apply 120 volt pressure to it. An analogy must be useful if you are completely unfamiliar with electricity. If you have a water pipe and the wall of the pipe is too thin to withstand the internal water pressure, the pipe will rupture. With electricity, the insulation covering the wire is like the wall of the pipe. If the insulation has insufficient strength for the voltage pressure applied, then electrical short circuits, grounding, sparks, heating, blown fuses, etc. may result. Remember, when you buy wire for your home or office electric circuits, be sure it has proper volt value. It is customary to use wire which is insulated for 600 volt for all home wiring and office wiring. Number 2, the ampere. This is the flow term. It is abbreviated A. It represents how much electricity is used each second. Here again, we can imagine a pipe carrying water. If we want a fast flow, that is a large number of gallons per minute through the pipe, then we use a large diameter pipe with electricity. If we want a large flow, used large diameter wire. Anytime we do not provide sufficient diameter pathway for the flow of electricity, the wire will get hot. It may burn and cause a fire if proper precautions are not used in installation. Always use the right diameter wire for the circuit. Wire size. Electrical wires are specified in terms of how many amperes can pass through them without overheating. From 15 to 20 circuits, such as are in your home. Wire sizes are number 12 and 14. For larger currents, sizes 10 and 8 are used. Notice that the wire size is larger as the number becomes smaller. For example, a wire size of 1 is much larger than a wire size of 22, gives the current carrying capacity of common wire size you will encounter. Sizes of wires. Conductors are manufactured in a variety of sizes with corresponding standardized code numbers. These code numbers are set by the American wire gauge, or is abbreviated as AWG. Table below shows partial list of the common size of wires. The lower the number of the wire, the bigger its size. The higher the number, the smaller its size. Here is the table for wire size in inches. American wire gauge size 8 has a diameter of 0.128. 10, it has 0.102. 12, it has 0.081. 14, it has 0.064. 16, it has 0.051. 18, it has 0.040. 20, it has 0.031. 22, it has 0.25. 24, it has 0.020. Conductors may come either in solid or stranded form. Each kind has its own function to meet. The need of body circuit both in the homes and industrial setting whenever the wire installation are to be made stable or fixed. Solid wires are used. On the other hand, stranded wires permit flexibility or easy handling. This kind of wire could be bent and rolled as in an appliance cord. For example, in house wiring installation, it is safe to use number 12. A wire higher than number 12, it is undesirable for such purpose. Number 3, the watt. This is the power term. It is abbreviated as W. It represents how much equivalent heat the volts and amperes produced if connected to an appliance. It represents how much energy is dissipated as light and heat from a light bulb. It is a measure of power consumed. Watts are determined by multiplying the volts by the ampere. The formula is watts equals to volt times ampere. This is important to us because if we plan to use an appliance which has a rating of 240 watts at 120 volt, then we can find the amperes which the circuit will have to be able to pass. Since the original formula is W equals to volt times ampere, we must transpose to find A. By algebraic manipulation, the formula becomes ampere equals to watts divided by volts. We then plug in the number and have 240 watts divided by 120 volt equals to 2 ampere. By the way, 240 watt is about right for a TV set since most home outlets individually are connected to pass at least 15 ampere. If nothing else is on the circuit, we can use TV and other appliances or lights on the circuit without problems. If you use an iron clothes and it is rated at 1000 watts, then note that the current is high. 1000 watts divided by 120 volts is equivalent to 8.33 ampere. Watts is the rate of use of electric power. Here is definition to explain watts in terms of the amount of work they can do for you. Summary. Volts is important term meaning pressure that forces current to flow and determines the amount of non-conductive covering of the wires in the insulation. We must always use wire with sufficient insulation to prevent breakdown. Ampere is the flow of electricity. If too much flow into a small wire, the wire gets hot, can burn the insulation, cause a breakdown, short circuit, and blow off fuses, or cause fire. Watts relates to power used. It is a term noted on electrical appliances and devices to tell us what kind of circuit we must have to operate the device satisfactorily. For example, a 100 watt, 120 volt light bulb will produce 100 watt of heat and light with a current of 0.83 ampere from 120 volt line. This ends my presentation.